So today we're going to be looking at the equation of a circle. So let us look at the fancy definition of what we mean to be a circle. So a circle is defined as the locus of all points in a plane that are a fixed distance from the centre. So let's think about what that means. Let's just draw a set of axes, and let's just draw a random circle. I'll just draw a really bad circle because I'll try and draw a nice one. So here's a circle. Now we've got our centre point here, and so we find it as a locus of all points. So everything that is within this circle and all the points that get rid of that. All the points that if we were to draw a point from our centre to the outside of our circle, and we were to sweep that round, that would cover all the points within our circle, which is the locus of all points in this plane, and the edge of the circle is a fixed distance defined by the radius from the centre. Now I really recommend you play with some equations of a circle with graphing software to get a real handle on what's happening with the equation of a circle. Now let's look at the general equation of a circle. So we've got our set of axes here, x and y, and here's our circle, and here's our centre point, and we're going to call the centre A, B. And here we've got some point P on the edge of our circle with coordinates x and y. Now, try and do it a bit better. Here we go. So here's our radius. Now let's think about this. If we draw a right angled triangle in our circle here and here, and we'll call this point Q. Now we can use Pythagoras on our triangle CQP, and that gives CQ squared plus PQ squared equals R squared. Now we should really just should have said this before. C is our centre here. Now CQ can be rewritten as x minus a. So Q, this is P point P is xy, but Q is on the same x coordinate here, like what? Yeah. So CQ is x minus a, and PQ is going to be y minus b. So if we put that into this, we will get x minus a squared plus y minus b squared equals r squared. Now this is the general equation of a circle. where the centre is A, B, and radius R. So let's look at some examples. So for these equations, we're going to write down the coordinates of the centre and the radius of each. So let's look at x squared plus y squared equals 4. So there's no A and there's no B, so the centre is going to be 0, 0, and the radius, remember that's r squared, so the radius will be the square root of 4, which is 2. Now let's look at this equation, x minus 2 squared plus y minus 4 squared equals 100. So the centre here is going to be 2, 4, and the radius r will be the square root of 100, which is 10. And finally, let's look at x plus 1 squared plus y minus 8 squared equals 12. So here the centre is going to be there. This is a positive plus 1, so that means the centre must be minus 1, and the y coordinate will be 8, the centre, and the radius r is going to be the square root of 12, and we can write that as a third, so it'll be 2 square root 3. So when it's a square root like this, put it into its simplest form as a third. Let's look at something a bit more tricky and a bit more involved. Well, firstly we'll do this one, then we'll look at something a bit more tricky. So, find the equation of the circle with centre minus 4, 3, and the radius is going to be 6. So we know the general form is x minus a squared plus y minus b squared equals to r squared. So this is a, this is b, so that will be x minus 4, so x plus 4 squared plus y minus 3 squared, and r squared is going to be 36. So now we'll look at one that's a bit more tricky. So A is the point um, 3, 0, and B is 7 minus 4. Find the equation of the circle that has AB as the diameter. So let's just make a wee sketch of what we're looking at. So we have point A it should be 3, 4, so that's point A, and B is 7 minus 4, so down here somewhere. And this is the diameter of a circle. So because the diameter, the halfway point from AB must be the centre C, and from C to A or C to B, that must be the radius. So we need to find the midpoint of AB, and that would be C. So C is going to be, so the x coordinates 3 plus 7 over 2 for the x coordinate, and then we 0 plus minus 4 the y coordinate over 2, so that will be 3 plus 7 is 4, divided by 2 is 2, minus 4 over 2 is going to be minus 2. Oh, sorry, 3 plus 5 is 10, sorry, over 2 is 5. I was taken away there. Sorry, so it's 5 minus 2. Now, the radius is equal to AC. So we can find the distance AC. So R is going to be the square root of 5 minus 3, so the x coordinates, all squared, plus minus 2 minus minus 0, all squared, which is going to give us the square root of 8. Therefore, the equation of the circle will be, so we've got x minus a squared plus y minus b squared equals r squared. So we've got the centre, so this is here. It's going to be x minus 5 squared plus y minus 2 is going to be plus 2 squared, and the square root of 8 is going to just be 8. And that's the equation of our circle. So let's look more closely at this equation. X minus a squared plus y minus b squared equals r squared. Now if we expand it, so let's expand the equation. That's going to give us x squared minus 2ax plus a squared plus y squared minus 2by plus b squared equals r squared. So you can expand that for yourself and you'll get this. Now let's rearrange this. So let's put the squared coefficients together, x and y. Let's put the x and y ones together. 2ax minus 2by, and then we'll have at the end here we'll have plus a squared plus b squared r squared, and let's actually bring the r squared over and that'll be equal to 0. Now we're going to just put brackets around this so we can look at this separately. When we write the equation of the circle in this form, we note some important characteristics. So, firstly, the coefficients of x squared and y squared are equal. Secondly, there is no xy term. And that's important when you're thinking of what a circle is. Now, we can write the expanded form of a circle as this. So we can write x squared plus y squared plus 2gx plus 2fy plus c equals 0, where minus g, it's meant to be a g not a y, and minus f are the centre, and where g squared plus f squared minus c is the radius. This is the equation of a circle in the, so we call this bit here, the expanded general form. So let's look at another example. So find the centre of, and the radius of x squared plus y squared plus 10x minus 8y minus 40 equals 0. Now just a quick note here, if you were to see an equation like this and not be told it was a circle, you could tell it was a circle because the coefficients on the x squared and y squared are the same, and there is no xy term in this equation. So, firstly, we're going to complete the square. So we'll do that by looking at the x terms and the y terms. So it's going to be for the x terms, x plus 5 squared minus 5 squared. So that's for the x terms. And then plus the y terms, so y, and it's minus 8, so it's going to be minus 4 squared minus 4 squared, and then we've got 40 minus 40 equals 0. So now we will gather terms. So we've got x plus 5, and that's going to be 20, and plus was to y minus 4 squared, and then we're going to, so we've got here, we've got minus 25 minus 16 minus 40 equals 0. We're going to take all that over and the other side, and so we'll get, oh, that's meant to have a squared there, plus y minus 4 squared, and that's going to be 81. So we've now got our form of a circle. So we know that the centre must be minus 5, that's plus 5 there, so it must be A must be minus 5, and 4, and the radius squared is 81, so R must be 9. Now, in GCSE we did quite a lot of things with circles, and it's just important to go over these different rules. So, if we have a circle here, and we've got a line that goes through the diameter, cuts the centre, we can do a nice right angled triangle here. That's point A, B and C, and the angle in a semi-circle is a right angle. What was right in there? Right angle. So our line through the centre makes this into the semicircle, and then we've got our right angle. Another one. Now we've got our centre, we're going to call it O, and we're going to draw a chord here, and the line, if you draw a line from the centre down to our chord, it's perpendicular, and these are the same length. So the perpendicular from the centre to the chord bisects the chord. So bisects means it basically cuts it in two. So every time you see the word bi, it means two. So it cuts it in two there. And then it's another one. So now we've got a tangent to our circle, and it hits our circle at point P. And we've got again a line from our centre O to point P, and that's going to be perpendicular. So the tangent to a circle at a point is perpendicular to the radius, at that point. So from these statements we can deduce that the triangle ABC is right angled at point B. Then the points A, B and C all lie on the circumference, and AC is the diameter. The perpendicular bisector of the chord must pass through the centre, and the radius and the line of point P on the circumference are at right angles, and therefore that must be a tangent. So they all kind of, if you were told you had the radius and it would hit a line beside the triangle point P, you can deduce that that line is tangential to the circle. All these facts that you learn in GCSE with circles, they need to be fresh in your mind when you're coming to some of these problems with circles at A level, because there will be an assumption that you know them, and the knowledge that these things have will help you solve the problems. So let's look at another example. A circle passes through the points P minus 1, 4, Q 1, 6 and R 5, 4. Find the equation of the circle. So we have point P minus 1, 4. We have Q, 1, 6. And R, 5, 4. And we have this circle here. And it has the centre here. So a circle passes through these points. So these 3 points are on the radius. So, because of that, we know that the centre of the circle, if we draw a perpendicular bisector, so we have a chord here, so that's Q and that's R. So we draw a chord between Q and R, and then we have this line coming down which is perpendicular. We also have a chord here between P and Q. We'd have another bisector. That doesn't look like a bisector, but it is. That's perpendicular, and these are equal in length. So, the centre lies perpendicular lies on the, sorry, no, it's a D, bisector PQ and on the perpendicular bisector QR. So let's find the midpoints of these 2 chords. So let's find the midpoint PQ. So that's going to be, so there's P and Q, so we'll have minus 1 plus 1 over 2 and 4 plus 6 over 2. So that's going to be 0, 5. And we're also going to find out the gradient of PQ. So that will be 6 minus 4 over 1 minus 1, which will be 1. Therefore, the gradient of the perpendicular bisector of PQ, so this one here, must be minus 1, because the gradient of that multiplied by the gradient of that must be equal to minus 1, therefore PQ must be minus 1. So we're going to do the same thing with this perpendicular bisector and this chord. So the midpoint, first of all, let's just get the equation. Let's get the equation for this bisector. Is going to be y minus 5 equals to minus 1 x minus 0. So that will give us y equals minus x plus 5. So that's the equation of this line here. Now, we want the midpoint of QR. So that's going to be 1 plus 5 over 2, 6 plus 4 over 2, and that will be 3, 5. Now we want the gradient of QR, so that's going to be 4 minus 6 over 5 minus 1, which is minus a half. Therefore, the gradient of the perpendicular bisector of QR must be equal to 2, and the equation of this bisector will be, using the same general formula, I'm just going to write it out, you'll end up with y equals 2x minus 1. So now we have these two equations. We have y equals minus x plus 5 and y equals 2x minus 1. So, solving the simultaneous equations are quite a simple one. We'll end up with x equals 2, y equals 3. So that's the centre points. And the radius is going to be of we'll put C here, and then we've got point R here, so this is the radius here. Of CR will be, you can use any point, you could use that one, you can use Q, or you can use P. But we'll use R because we've not used R yet. 5 minus 2 squared plus 4 minus 3 squared will give us the square root of 10. Now putting this into our general form of the equation for a circle, x minus 2 squared plus y minus 3 squared equals 10. So I hope that helps.